This is Green Worksheet 2.4, numbers 7 through 13. I'm going to get you started here to help you out. I'll do number 7 for you. I'll do number 11 for you. And I'll just let you know in number 10 that it's a little easier than multiplying by the conjugate, complex conjugate in 10. You can actually just multiply top and bottom by I. Let's see what happens there. To get the imaginary part out of the denominator. Our goal is to make that denominator real, so that should achieve that goal in that problem. So go ahead and try that and see what you get. We'll discuss it when we get together again. In number 7, we're going to FOIL this. First times first in blue. Outside in green. Inside in red, and the last in black, minus 12i squared. I'm going to take up some space here to the right to finish this problem. I'm going to highlight in yellow two things that can be combined. Okay, that's going to be 31i. And then in blue, I'm going to highlight these two parts, because they're actually the two real parts that we can combine. We have a negative 20 and the negative 12i squared. We learned that this actually just becomes plus 12. The I squared cancels and makes the minus sign turn to plus. So I have negative 20 plus 12, giving me negative 8 with a plus 31i. That's the answer to number 7. Negative 8 plus 31i. Okay? Number 11, I'm going to give myself some more room and bring it down here. 3 minus 2i is up top. 4 minus 3i is in the bottom. Third period today, I made the analogy that we're kind of simplifying this fraction. If you think about something simple from elementary school, when you simplified a fraction, your goal was to reduce it. We turned something like that into 1/2. Similar idea here. A little trickier because we're older now and smarter now too. So with these problems, to simplify, I'm going to put parentheses around the bottom and put a parentheses next to it. I'm going to copy and paste this over to here, but instead of 4 minus 3i, I'm going to make its complex conjugate 4 plus 3i. Whatever I do in the bottom, you want to do the same thing in the top. So we're going to multiply the top also by 4 plus 3i. This is legal because anytime you multiply a fraction by the same thing on top and bottom, you're technically multiplying by 1. So you're not changing the value, you're just changing how it looks. The denominator I usually do first because it should be easier. When you multiply conjugates, you only need to worry about first times first, which is 16. And last times last, which is negative 9i squared. That's going to turn that into a real number, because this becomes plus 9. The I squared goes away. I squared is negative 1, so it turns it into 16 plus 9, so our denominator is 25. We turned that imaginary or complex denominator into the real number 25. Up in the numerator, we'll do our separate colors here like I've been doing. Black gives us 12. Red gives us 9i plus 9i. Green gives me minus 8i. I'm going to be able to combine red and green in a moment. Blue gives me minus 6i squared. And I'll be able to combine black and blue in a moment. In fact, let's do it right now. Let's take 12 and add 6, because I squared is going to turn that into plus 6. Quick reason why, in case you're confused by this. Negative 6i squared is like negative 6 times negative 1, because that's what I squared equals. Negative 6 times negative 1 is plus positive 6. All right? So up top there I have 12 plus 6, which is 18. That's combining the black and blue. Combining the red and the green would give me plus 1i. Now, if you want to check out the separate video I have for this, it's a quick 2-minute video to show you what happens when this doesn't work out nicely. When the top and bottom here, those two numbers, the A and the B, are not divisible by the bottom number. All I want you to do is separate it into 18 over 25 plus 1 over 25i. We are now in A plus BI form, which is what they wanted us to do. Whoops, up in the directions here, in the form A plus BI. That is your answer to number 11. Go ahead and try 12 and 10, and we'll see how you did tomorrow.